Okay, 1 o'clock Eastern. I think we are good to go. Thumbs up if you guys can hear me. All right, see a multiple. Wonderful. All right, we're good to go. Welcome everyone. My name is Malik, and it is wonderful to be able to have this exchange at a forum like the Canadian Symposium for Remote Sensing. I'm happy to be able to host this event. I caught a little bit of the introductory stuff this morning, so really great to be able to do this. Um, Indeed, the last year and a half of our lives have been weird, but in some ways, it has reminded us that we naturally like to seek refuge and access the natural environment that surrounds us and the built one we inhabit. Basements and home offices perhaps did not suit all of us, and as this pandemic dies down, we are reminded of the importance of maintaining and improving the places we live in, the land used to grow food, and those environments we depend on for clean air and water. In this time of data proliferation, it is no surprise that as geospatial practitioners, we have overlapped with the contemporary high-performing data analysis tools popularly associated with the term AI or artificial intelligence. It is also true that in our domain, we overlap heavily with a branch of artificial intelligence called machine vision, one which seeks to develop computer routines that see, analyze, and understand the visual world. In our discussion today, we will additionally hear about AI used for the point, the pixel, and the tabulated data form. While fundamentally AI has changed the way we treat and utilize data, the concepts of training and inferring are and have been for so long at the core of any numerical modeling we do in the geospatial world. Today, we aim to discuss how the broader domain of AI has advanced the way we analyze and address geospatial problems, how it will do so in the future, and we will raise questions about accessibility and the common user's ability to leverage an AI-based solution. I'll be honest, this conversation has the potential to be an infinitely geeky science communication podcast, and I'd like to remind you that you willingly showed up to this. Jokes aside, I personally am excited for this dialogue, for the stuff that will transpire in the session, and for the follow-up from the audience afterwards. As someone working at an organization leading the development of remote sensing hardware and software for both terrestrial and marine applications, I am keen to ensure that any development that industry makes, especially on the AI front, is accessed and put to good use by students, government groups, and businesses trying to make their way in this GeoAI space. It is my pleasure to be able to moderate between the panel we have today, which represents various domains, geographies, and visions for GeoAI in Canada. Our panel consists of Dr. Gulu Sun, Associate Professor of Geomatics Engineering at York University, Liam Lab Morisset, Director of R&D at the Interdisciplinary Center for the Development of Ocean Mapping, Mike Parlow, Team Lead for the LiDAR Inventory Group at Foresight Consultants Limited, Andrew Sitt, Product Manager for LiDAR Software Solutions at Teledyne Optech, Burns Foster, Innovation Manager at Teledyne Keras, and myself, Malik Singer, Product Manager for Airborne at Teledyne Optech. One quick word of housekeeping. We are reserving 15 to 20 minutes at the end of the discussion to do a Q&A with the audience. So please feel free to pipe in with your questions. Use the Q&A function for questions that you'd like to send to the panelists and myself. The chat function is reserved for technical issues in case you need to reach out to the event organizers. We also have a poll that is running in case you'd like to get in touch with us. You can leave your email and we'll happily reach out after the chat. So with that, let's dive straight in with a roundtable. I'll start with Mike. In a few words, Mike, can you describe what you do what about what you do is geospatial, and what about it employs AI?
Sure, thanks, Malik. As you mentioned, I'm the team lead for remote sensing industries here, inventories rather, here at Foresight Consultants. We bring in LiDAR and imagery information, and we try to segment individual trees out of that point cloud and produce individual tree inventories for forest clients in Canada and the US. So it's inherently geospatial. Everything is somewhere. And then my group in particular specialize in using AI to identify species for those individual trees. At its core, we're using LiDAR, we're using aerial laser scanning data, but we'll use anything that we can get our hands on to help predict the individual tree species.
Thanks, Mike. So guys, everything is somewhere is right now the competing tagline. So you guys, one of you has to slam dunk that. We need to. Let's go. Same question. Briefly describe what you do. What about it is geospatial and AI? Guno?
Hi, Malik. Hi. Yes, I'm PI of the Augmented Urban Space Modeling Laboratory at York University Lassen School of Engineering. So my main research topic is to reconstruct the high fidelity three-dimensional models and representing them with high detailed primitives of large-scale built and natural environments using multimodal remote sensing system. So the visual AI pipeline, such as deep neural convolution neural networks, is a central part of my research program. And one of the latest research projects that I'm doing now is closely working with Telet and Optech for semantic segmentation, 3D object detections in SLAMs, and which leading to the efficient digital twinning of cities and utility network kind of things. So that's sort of a brief, my summary of what I'm doing here.
Yeah, wonderful. Thanks, Guno. Guillaume, same for you. I think you're muted, Guillaume.
It's not a video conference until somebody gets to mute. Well, hi, Malik. Here at CITCO, basically we focus on the, let's call it hydrospatial kind of aspect of things. Basically, we work in the marine geomatics sector. So we use a lot of AI, of course, for point cloud segmentation, but also for object recognition inside 2D and 3D data. We also use time series analysis to classify bottom substrates. So our main focus is basically applying AI to mostly acoustic and optical data.
Mm-hmm. Thank you, Guillaume. Andrew?
Yeah, thanks, Malik. Yeah, so as you mentioned earlier, I work for Teledyne Optech as well as same as you, and we're manufacturers of LiDAR systems. So we are producers of massive amounts of geospatial data, and sort of my role at Optech is as product manager for software. And as a sensor manufacturer, we make these awesome sensors, and really they're not very useful unless you've got the software to go with it. So I'm sort of heavily into geospatial data in general, and more recently into how to use AI to solve some of those data related problems.
Mm-hmm. Thanks, Andrew. And last but not least, our friend on the East Coast, Burns.
Thanks, Malik. Yes, as innovation manager, it's kind of a broad title, but I guess it's because it's a broad application. With kind of this, we're straddling between Keras and Optech, between the marine and the land, and I've really been leading the AI group here for the last 3 years, starting with sonar data, but of course, in many ways, a point cloud is a point cloud. So of course, we've expanded quite a bit into LiDAR as well.
Wonderful. Thanks, Burns. Guillaume, I know your background is heavily in mathematics and algorithm development, but you also are in the, as you said, hydrospatial world, so where things exist in space. So can you define for us, in your perspective, what AI is and what the major tools that AI offers to the study of our domain?
Well, that's a very heavy question. First of all, I think that recently the trend has been to mix deep learning and AI altogether. But I believe that there's a necessary distinction here. AI is basically, the science of making smart systems that are able to achieve their own conclusions, which is a much broader topic than what we usually focus as AI, which is mostly convolutional neural networks nowadays. So, but it really includes all the tools that comprise, machine vision, and even rule-based inference systems, or little expert systems. So I believe that most of the tools nowadays are being focused on deep learning. However, there's a very nice trend, kind of a back to the basics kind of things, in order to let's say manage the issues that arise from a deep learning network, as people learn that you can't just throw GPUs at massive amounts of GPUs at massive data and get good results. You have to manage all different let's say edge cases in there, and from there all sorts of different techniques are being dug back from the past in order to manage these issues. So I believe that the scope of AI has really gone into kind of a funnel effect, but it's starting to broaden back in it, so that we can effectively use the tools that we have now. And of course, we have now we have the computer power, we have the means for our ambitions using as I mentioned, massive GPU systems, massive storage systems. But the algorithms, the principles are all there, so they're just waiting to be used, really.
Yeah, thanks, Guillaume. So maybe Guno, maybe you can help us kind of get a use case on this. So let me do a hypothetical. Say I work in the city of Toronto, and we have decades worth of air photos of the city, and we have locations of where the streets have degraded over time, and they've been repaired. So how can an AI pipeline help us identify areas where the road is degrading? And is there an ability for us to do this predictively into the future?
Yeah, so right. So the AI, well, the core part of the AI is data teaching what the computer vision can do, right? So basically mimic the human vision system to identify what the problems in the road. And I guess I can start to talk about what are the limitations and why we couldn't use it in practice today and in the governments for understanding the condition of pavements, road damages. And because the traditional computer vision algorithms is not robust enough for generalizing all different categories of damages and under the different condition of background of pavement. So it works sometimes, it's not working sometimes, and also very sensitive to the sensors. You might use very high-end airborne or mobile mapping systems. You might want to use very consumer grade and camera system you mounted on a driving car. So different sensors, different quality of data set, and need a different algorithm. It doesn't actually simply not working. So the AI pipeline is simply much easier for you to develop the computer vision system more generalized and working robustly in a different conditions. But the question is, however, the understanding, the usually many different stages for, evaluating the condition of pavement road. And number one is you might have 60 different categories, right? And one category has severity, different types of. And those practice is a little different. For example, Ontario is different way of doing it in Quebec, and Canada is doing the different practice in different things. So a lot of different categories can be addressed. So different conditions. So still the data centric needs a lot of other, the very huge amount of data and put it together in a sort of a standardized way of anatomy categories. That might be very helpful. And so once you build this data part, and it's very easy to build the pipeline, and quite matured networks is available already. And then you might be using it and for identify the certain areas which might be more problems, so that you can deploy more human resources for, rather than you uniformly deploy the human resources to investigate it everywhere. But you can allocate it differently, more effectively human resources to work on and that you're technically looking at the more detailed problems of a payment that can help. So I don't know if my answer is help, but an AI pipeline is actually many people are interested in is there's no bottleneck for build the neural network itself, how to detect it. And but however, very question marks about how we well prepare the data set and how we're going to use it and how we're going to take it in a actually practice in the government side and how we're going to integrate with the decision making. Those parts still is very open space for me.
Yeah, thank you, Bruno. I think you touched on a few themes that we will get to later, which is availability of data, benchmarking, kind of stuff along those lines. So yeah, thanks for seeding the conversation. Burns, maybe I'll do a similar question to you. How is perhaps in the 3D point cloud world, what's a use case of how AI is being used to tackle a problem there?
Yeah, the big one, of course, we tackled. So I've got some self-interest in this answer, but the first one we tackled was noise, because of course, the marine environment's quite noisy. We're using acoustics in an acoustically noisy environment. So we, these days, sensors are getting, incredibly sophisticated, and very accurate and everything else, but it doesn't matter, if you're out surveying and another ship comes by with a similar sensor picking at the same frequency, you're going to get noise. Like there's not a lot these high-end systems can do to control some of that. So that was a big one for us, is trying to automate the identification and removal of this noise from the platforms. But of course, there's other applications very similar to terrestrial, like object detection, finding stuff. The interesting thing on the sea, when you're even flying a LiDAR survey, on land somewhere, there's always something in the scene. There's a tree or a building or a car or a person. Underwater is a bit different. You can have vast stretches of sort of ocean desert where there is nothing. It's just sand, silt, mud, whatever. And then all of a sudden there's a big rock. Okay, well, do I need to scan through terabytes of data to find one rock? There's, we can make that a bit more efficient with some deep learning, or not even deep learning, but even just, pure computer vision approaches.
Yeah, interesting. It's interesting you mentioned, because I mean, for myself, someone mostly working on the terrestrial end, I don't typically get excited when I find the rock in data. But yeah, no, this really speaks to the idea of tuning classifiers and object identifiers to find something that is of interest to the practitioner. Yeah, thanks, Burns. So our panel is about advancements in GeoAI. We do want to spend quite a bit of time on the advancements before we segue into some of the issues and kind of our future vision. So let's speak a little bit about advancements and how AI has changed the way we do work as geo and hydrospatial practitioners. Again, I'll start with Mike here. So Mike, maybe can you speak a little bit about trends that you have encountered on how AI is used in the forestry space?
Sure. So speaking very specifically about my little world, we've been using AI to sift through LiDAR point clouds and find trees, identify trees for many years, and that's really evolved. When we began that process, there were absolutely academic papers out there doing it, but in industry, it really wasn't there. So that's part of it. But away from our focus on individual tree inventories and broader timber inventories, AI is being used to group and assess traditional timber polygonal inventory, so just polygons, that describe the content across a land base in a way that is useful for forest managers to make decisions. AI is being used in the wildfire group to determine where, if an ignition point occurs, given these fuel loads, where is that going to lead? Where do we have to worry? So it's really quite widespread. Also, forestry is complicated and extremely regulated, and just finding areas that you're allowed to harvest takes a fair bit of analysis to say, okay, well, given all of these criteria, where could we actually go out and direct our clients to harvest?
And how does AI make that last one easier? Kind of identifying areas that are
It's
to
just
be harvested.
precisely. So we're juggling all of those attributes and priorities to arrive at a predicted optimal solution across the land base. We're looking for the right product mix that's at the right age, at the right species, that is in a permissible area to be harvested.
And when you say timber content, what kind of attributes are you trying to extract from the data at hand?
At its core level, at the tree level, we're looking for the species, the diameter of breast height of the trunk itself, and from that information and the height that we're getting from the LiDAR, Malik, we're then going to calculate volume, piece size, and a number of attributes that the client is going to need to determine which mill is this log going to go to, in what sort of time frame.
Right. Okay. Great. And you also mentioned classification of species. Is this kind of quite different than the way kind of we used to do classifications prior to the buzz of deep learning?
Yeah, I can't speak to it, Malik. I'm thinking yes. The reality is there are a number of approaches to identifying species. We sort of started at an individual tree level, and we're looking at the LiDAR to give us branching patterns and crown density and just all that great reflectivity information to try and determine species. But you know, if you don't have that kind of information available, you're going to use perhaps satellite or other imagery available, and maybe you're not getting to the individual tree level, but you're at a pixel level, you're getting a pretty decent accuracy on what the species mix is in a particular area.
Right, understood. Guno, I think kind of for many years in kind of in the geospatial world, whether it's in academia or in industry, we used classifiers, we used maximum likelihood, we used random forest, we used k-means. So what are the major shifts, however, that the neural net introduces when it comes to classification?
Right. So the classifiers that you mentioned, and we call the shallow learner, which means that we're using relatively much smaller amounts of data set, and plus the handcrafted features. The feature means sort of how we're going to define the object of interest in terms of vectors, right? And the colors, maybe it's a very unique representation of a certain object. Usually the shallow learners requires the handcrafted features, and which means that developer himself and herself and they define how represent an object by themselves, and then those back to the features is going to be inputted to the shallow learner. That's the biggest difference from the deep learning. And the deep learning is they not requires you to represent them. It's just the data is thrown to them, and through the deep neural networks, and they actually driving how to define the object saliency, so how to represent them. So that is a huge difference. So therefore, how we uniquely represent an object is not relies on myself, is actually generalizable. So it can be uniquely represented in whatever the situations that object is inputted in. So that's make us the deep neural networks, although and a lot of the data set is required, but however it's much easier for us to be the generalize in a different diverse environments, which means that I built the PhD writer, the thesis can be used in Finland and used in Canadian environments and in other environments as well. So that's a huge benefit. So I can now say I cannot going back to those shallow learner after I actually enjoy the benefit from the deep learning, this and that. Okay.
Yeah, so I'll kind of do a quick follow-up here. So if we let's just linger a little bit on the idea of crafting, like hand crafting features. So kind of when you say that, I think of, say we have a scene that is an urban scene, and we're trying to identify features of interest, say sidewalks or buildings.
That's right.
Traditionally, as a practitioner, I'm thinking of let's identify things that are linear, or let's identify things that are gray, or things that have certain criteria. But with the neural net, there probably are some features that are intuitive to us, but there are kind of deeper layers that are basically arithmetic. I mean, they're not intuitive to us, but they mean something to the net. Is
That's
that
right.
kind of the idea?
Yeah, data themselves driving how to represent them themselves. That's what the neural network can help.
Understood. Great. Thanks, Kuno. So maybe let's make it just slightly more complicated with the 3D. And Andrew, can you kind of speak to how classification has evolved with artificial intelligence in the point cloud world?
Yeah, so I mean, I think one example that comes to mind is sort of bridging the gap between 2D and 3D, where a lot of the time we are still working with 2D data, but trying to make 3D decisions or trying to get 3D information. So a good example of that is sort of self-driving cars or stereo imagery or structure from motion, where we're taking this 2D data, which is basically camera images, and trying to either build a 3D model from that, or make decisions about what to do in a 3D world that you're driving through, or things like that. And then sort of and that I think is advancing still, but is relatively sort of old news. I think where we're heading, at least at Optech and Keras, and where a lot of the rest of the world is also heading, is using that 3D data as input. So using point clouds as input for a classifier, rather than starting in 2D and deducing the 3D from the AI. So a good example of that is sort of, as Burns said, removing noise, or even doing sort of semantic segmentation of a point cloud, to say, these points belong to a tree, these points belong to a building. And obviously, with that third dimension of data, the problem does get a whole lot more complicated, not just sort of on the theoretical math side, but also just on the implementation and practicality side, because, as soon as you're dealing with 3D instead of 2D maps, that data just grew by a factor of n, right? Like, instead anything that was n squared is now n cubed.
Right.
So there's some serious challenges that need to be overcome there.
And what's a good use case of a classification problem in the point cloud world?
Well, I think, again, I'll steal the one from Burns and the one sort of right behind me here, which is removing noise. And I think that one is really well suited to be done in 3D, because, as you can sort of see in this picture behind me, it's possible for that noise to mix in with the ground or with the objects that you're interested in. And, it's very difficult even for a human operator to remove it. Yeah.
Yeah, thanks, Andrew. So let's kind of move slightly up from classification and talk about object detection. Guillaume, how does that look like in a world where tools have some kind of deep learning at their core?
Yes, thank you, Malik. Basically, we have two big scenarios here at CITCO. We have, of course, the traditional known object detection, which is the good old ATR, automatic target detection. We have targets that have a known shape and we're looking for. This is we pretty much call it a solved problem. You just throw neural networks and a training data set at it, and that's done and done. Where things get a little more, let's say, interesting is in the unsupervised detection area. Namely, we have two big problems here that we're working on. Of course, shipwreck detection. As you may know, a ship, when it sinks, it falls into all sorts of different pieces. The geometries get distorted. And basically you kind of lose the generic shape of the object. So finding shipwrecks can be a very hard endeavor. Hopefully, as Burns mentioned, you usually have a whole desert and you're looking for that very big structure in the desert, and you want to avoid reaching through sifting through terabytes of data in order to get to that interesting area. So we use unsupervised machine vision based methods in order to let's say focus the interest on zones of interest, and from there we can dig into a much more restricted data set. So these are basically the two big paradigms in object detection that we're working with. Did we lose Malik?
I think we've lost Malik.
I see.
Yes, his bandwidth has gone down.
If we had to lose one guy, wow.
Well, I guess,
You know what?
I mean,
I can bring up some of his notes and maybe fill in the gap a little bit. Let me just find where he left off. I just found his notes page here.
we do have a question in the Q&A. It has been answered, but if you do want to look at that as well.
I kind of like this question, and I know Guillaume. I remember back at Shallow Survey 2018 in St. John's, we had this. There was we had a panel very similar to this with more sort of a maritime audience. We had a Q&A session, and then towards the end, this group of students, and I think they were undergrad or maybe early graduate students, came to the microphone and said, "Are we wasting our time, getting an education? Are we going to be out of a job by the time we graduate? That all this work's going to go away?" And the short answer is no. I mean, from my perspective, working in processing both maritime and terrestrial data, I see AI as a tool, but it's a very, very, very long way from replacing a human. What it hopefully will do is make it a lot less monotonous. So you see that picture behind Andrew, you can imagine, that's what, like 30 seconds of data, Andrew?
I think even less, maybe 2 or 3 seconds. Yeah.
Yeah, exactly. So you imagine what's behind Andrew times, 100, and some poor sap has to sit there and troll through that data and labeling, noise, not noise. I don't think anyone really wants to do that as a professional career. Right. So I really think, that what AI is going to do is going to make life easier. The interesting bits is what's in the red there. What's the not noise. And that's where the human comes in.
Oh, that's a great answer, Burns. I think I found where Malik left off, so I'll throw the next question over to Mike. And it's related to time series data. So, how is AI being used with time series analysis? I guess in your industry, it would be sort of to predict growth or to predict the yield that you might get out of a patch of forest.
Precisely. There are a lot of established models around that already, Andrew. And so AI is kind of standing on the shoulders of giants there. There's been a ton of biometric work already on that front. Some of the more interesting work, again, going back to my colleagues in the wildfire group, trying to look at predictions of if a fire were to occur over time, what's the most at-risk sections of a forest or the borders of a community or what have you. From a temporal side, we can also try to predict change going forward on that. We don't see LiDAR flown over forests sequentially so very often, but it's definitely something that's coming and could be used even more than has been in past.
Great. Yeah. So so I assume you know, are the models that you're sort of, you know, standing on the shoulders of, are you using any sort of AI or neural network sort of techniques to employ those models, or is it just sort of still in that domain of you know, heuristic algorithms?
Right. No, and again, they're being adapted for use in AI. The fundamentals are all very much established, but we're suddenly able to expand them and use attribution that was previously not possible.
Great.
So I'm back, and of course that happened. Of course, everything crashed, but I'm back, and thank you, Andrew. I don't know where you guys made it, but what was the last thing you covered?
It's the time series data.
Fantastic. Okay, fantastic, great. Yeah, so I think let's do a question up for grabs, and kind of besides classification and object detection, what is a tool from the AI toolbox that has advanced our understanding of phenomena from the physical world? And this is up for grabs, so anyone can just start speaking. And I think so okay, maybe I'll seed this a little bit. So we kind of typically talk about classification, we typically talk about object detection, but I'm sure there are instances of instance segmentation or stuff from the moving world of autonomous mobility and whatnot, where some kind of AI is mobilized. So what is that class of tools called, and how is it being mobilized in autonomous mobility? Kuno, I see you shaking your head, so I'm gonna give you that question.
So you're talking about the technology itself, like the neural network technology itself, of how detect the object.
Yeah. So what from the AI toolbox do we use to help us in the problem of moving in an unknown space?
I see. Well, I'm particularly involved in the autonomous train project, so that we're building the perception module for detecting unknown object and a known object, right? So there are tons of technology, neural network is available, and the challenging is, I don't know, so the way that how it works is that, again, you know, all the saliency representation is run by data, right? And then they do either in just you know, the bounding boxes representation, which means that, you know, encompassing, they're predicting the very simple representation of object in 3D and the cuboid, and then they regressing, predicting the position of the bounding boxes. And other people's, and even further, they segmenting inside the points, which is actually, you know, the containing that boxes, which is relevant to your concern. So that's more instance segmentation plus bounding box representation too. So there are many ways technology, you know, who is interested in more high frequency boundary detections, or just the key points based detections. There are numbers of ways of detecting in instances. But the autonomous wise, you know, what things are a little question mark is that the neural network is trained with annotated data, right? And you're saying hundreds of different categories, but what about the unknowns, is unseen object is just popping in the road, and how the network is actually can detect them? So that is one of the questions. How we going to develop the neural networks to detect the unseen object, right? So which is not trained. And the second is, you know, some of the categories of instances is a very, very long tail. So it's a very small set of a training is only available because this is not the commonly, highly frequently you can see and while you're driving, right? So then how are we going to balance it out, this training? So the long tail problem and the tons of problems we're talking about. I think I'm not sure, but 3D is one thing that I want to say is that annotating the instances from the 3D point cloud is very challenging. It's way different from you can annotate it from image. So I think the people are slowly moving towards, but it's not very convenient tool is available for annotating the things and stuffs and from the 3D point cloud.
Yeah, thanks, Guru. This is a good segue into some of the limitations that we want to discuss up next. Before we do so, maybe Burns can give us a little bit of a summary of how we've improved over the last couple of years. So, kind of when it comes to accessing hardware needed to fix a problem via some GeoAI routines, or whether it is access to libraries or data, how has kind of doing AI or doing GeoAI changed now versus 2 or 3 years ago?
Yeah, it's really interesting. Kind of the cool thing is, a lot of these big software companies, like Google, Facebook, Microsoft, others, they've built up a lot of these AI libraries and then just put them on the open web for anyone to grab. And that spawns, just kind of this massive feedback loop of research and industry, picking up these libraries and adding to them and plugging in. So now versus 5 years ago, it's an absolutely massive difference in how easy it is for someone to just grab one of these libraries to solve a specific problem. On the hardware side, GPUs really kind of changed the game too. That being said, for anyone in the business right now, it is just about impossible to buy a GPU at the moment with semiconductor shortage and crypto mining and all that stuff. It's a challenge at the moment, but hopefully that will pass soon.
Yeah, thanks, Burns.
Yeah, Malik, I would just add to that, the cloud side is also making it a whole lot easier, right? So if you can't go and buy a GPU, from Best Buy or from your tech shop of choice, send it up to the cloud, stand up a virtual machine, the proliferation of cloud services and the ease of use of standing one up and implementing something on it is also making it a whole lot easier.
Yeah, indeed. Thank you, Andrew.
Excellent point, Andrew.
Let's just talk a little bit about some bottlenecks that we encounter as practitioners of Geo and AI. I'll toss this one to Mike. When it comes to communication, do you find that there is a hurdle in trying to sell or convince a product that is derived from an AI routine?
Yeah, I think it's new enough in the forest industry that we have to spend a fair bit of time not only explaining how we go about it and what the background validation is, but we conduct extensive field validations and share that with the client, perhaps more than we had originally thought we were going to need to, but it's all good. I mean, people have to understand what's going on and they have to trust the process. But if you had told me that we were going to need to validate hundreds of sites on a project in exquisite detail going in, I maybe wouldn't have believed you, Malik. I would have said, well, look here, the R-square is right here. But indeed, that's probably the biggest one.
Right. Guillaume, do you have similar experience in kind of trying to communicate to an end user a AI-derived product?
Yeah, I mean, there's two things. Of course, there's let's call it disbelief, which I think Mike really covered. But at the other end of the spectrum is expectations management, which is also as critical. I mean, there's a huge trend nowadays, especially in let's say non-technical people, that you can just whip out your corporate credit card and say, "I would like one AI, please." So that's something that we have to work with, and sadly, there's an entire ecosystem of let's call it not toxic, but let's say shady startups, and that really fuel this unreasonable expectations regarding AI. So, with boosted figures on extremely restricted data sets or like that. So there's a very large effort to be made in terms of both expectations management, of course, bringing organizational culture to the point where data acquisition is done in the proper way, properly instrument business processes so that you can get quality data, because AI is really a garbage in, garbage out kind of deal. So if you don't properly instrument and manage all the different non-technical aspects of the thing, your system won't work. So
Yeah, thanks, Guillaume. So I mean, Guno, I know that you spent a considerable amount of time changing the structure of your lab and having a lot of the work being AI driven. So how do you deal with this, or actually, do you encounter or similarly a communication issue, kind of trying to convince someone of an AI derived solution?
Okay, well, yes. Again, I am involved in one project. Is about the autonomous train. So the autonomous trains, we have automated trains. This train we already have which is localized train based on the Wi-Fi, the triangulation. Then infrastructure is malfunction. Then train actually have to be taken over by the human. Downtime is huge. So the industry want to change this. So just using the AI, so moving and from the accident points to the safe zone, and without waiting the humans to take over the control. The problem is the safety certification. So it is really hard for AI to be adapted by the industry and safety concerns. Okay, so we have to prove it. This AI-based the movement and control is safe enough compared to existing control system. So they have regulatory bodies, and how we're going to convince them to accept that this is enough safety. So this is the one of the examples that I'm dealing with, and how we're going to make the society to accept an AI and using it, and when they deal with the public safety. So usually they compare existing computer vision algorithms, they actually using it, right? Non-deep learning based, and compared to the deep learning. But a lot of other ways of doing it. That is, the long story, but still a lot of people struggling to penetrate that one. And because the AI is sometimes known to be very sensitive to the adversarial noise, it's very little, the random noises, but suddenly they conducting very stupid decisions, right? So that is one big question, right? And I can tell you as an example, right?
Yeah. Thanks, Uno. I think for us on the part of the industry is we generally have a pull for automation and analytics. Kind of these are two themes that continuously come to us as people in industry. How can we automate the processing of vast amount of data, and how can we leverage faster, smarter, more unique analytics? And recently, and I mean, Burns and Andrew are leading this on our end, it's been a lot of AI-driven solutions, whether it is classification of noise or features or other kinds of problems. I think we sometimes get some feedback from users that are very protective of their data, and they feel like they need to do stuff manually. But then you get the other end of the spectrum, who's people like you said, can't afford a downtime and can't afford to wait until the insight is generated. So they do kind of capitalize on the solutions that we build, and they do welcome them quite readily. Let's talk a little bit about the availability of labeled data. Maybe Andrew, you can take that. Kind of, it seems like the availability of labeled data isn't kind of always there, and do you like how do we address that? Is it a technical problem? Is it a partnership problem? How do you view the availability of labeled data?
Yeah, I mean, I think it's in some ways all of the above, like it is technical in the sense that, okay, where are we going to store all this data, especially when we're living in sort of in our world at Teledyne Optech with point clouds, these data sets can get quite huge. So having some, centralized repository of labeled data is not a trivial to manage that data. With that said, there are definitely sort of people working on that. There's an increasing sort of drive from the research and open source communities that are helping to feed that. But it's definitely a challenge. I would say for us, it's been one of the biggest challenges in implementing these things. And I think sort of, maybe the path forward or what I hope is the path forward is to find creative ways that to sort of mine that data. So, just as an example from sort of that's maybe a little bit more relatable for people is like, I don't know if you remember sort of in the early days of Facebook, anytime you posted a picture, they would ask you, hey, do you want to tag any of your friends in this photo? Well, guess what? They just got a huge repository of facial recognition data, training data that they could then employ and train an algorithm to recognize faces. So, finding creative ways like that to solicit sort of labeling services as part of your product inherently is very interesting to me. I haven't cracked it with the point cloud yet, but I'd like to.
Actually, Kuno, did you want to follow up?
Oh yeah, I will say something about it, right? If you don't mind. And labeling, yes, this issue is, it's very challenging. And the AI pipeline is 80% of AI. You must spend your 80% of the time spent on an annotation problem, right? So it's a huge amount of investments that have to be done. Regarding the remote sensing society, I think the benchmark is thanks to a lot of other great minds intellects, and they provide an open benchmark to the community, so we enjoy the benefit. And however, the AI community is also a little bit of research is a bias to existing high quality benchmark, right? So we feel now the more diverse benchmarks is needed for, and particularly remote sensing community. Still, we don't have very good fine-grained benchmark yet, like an oceanography, ocean mapping community. I'm not quite sure, but the forest as well and the other groups, and still compared to little civil and industry-oriented computer vision community and environmental communities that doesn't actually have very diversified, fine-grained benchmarking, not yet. So that's something that as a community we have to a little bit more working together, and not just particularly led by the academics and the working together with the industry for driving this high-quality benchmark data set. The other thing is, I think the MLOps is now people talking about it, and one competition, very interesting things, and led by Andrew Leung. So maybe we don't need many data set. We can improve the performance only by improving the quality of data set. So that's something that we need to also bear in mind, how we can improve the quality of annotation, which is affecting to the quality of the performance things. The third one is, I don't know, one company has many clients. The nature of the data ownership is they do not want to share their annotated data set. But actually, if they're sharing them, then the baseline, the performance can be improved, and then they can add their own values based on that. So I think the industry also have to understand it, and not owning the data set itself is protecting the properties, but if they can sharing, they also can benefit, they gain the benefit as well. So maybe the hybriding one on hand and the owned data ship, but also the sort of sharing the general part of the networks with other partners, and that would be quite interesting to see in future. That's what
Yes, thank you, Bruno. Yeah, I think benchmarking is an important one. Mike, I wonder if kind of maybe in your industry or generally, are there kind of standards to which we are trying to adhere to when it comes to kind of a benchmark that we're trying to work towards when it comes to kind of classification of species or a similar kind of problem?
Yeah, so there's no benchmark per se for classification of species. The forest industry has, by province, established standards around what a forest inventory looks like.
Right.
And they have, in some cases, mandated what the procedure should be to achieve the end result. And we're hoping to help them find that what they really want to do is specify what should the result look like per standards. And it doesn't matter how you get there, because you can get there using AI, you can get there using the data that's available to you. It shouldn't matter that 17 different people didn't look at this particular tree. Is the point there, I think. So
yeah, thank you, Mike. I do want to talk a little bit about education, and as I said earlier, for a long time we used methods that now are called, for example, machine learning, but we never called them machine learning once upon a time. So I'll pose this question to Bruno, since he's the one in academia here. Can you talk a little bit about the role that us as people in geospatial and or in remote sensing, our education at an undergraduate or graduate level, do we receive that training sufficiently? Are we developers of it? Are we receptors of it? Can you just kind of talk a little bit about that topic?
Yeah, definitely. But I cannot say the other department curriculums. I only can say, based on my observation experience within York University and other the engineering and a little bit of a geography and environment science. Something that I make a comment, it cannot be generalizable. But my observation is it's a huge problem. So for the running the labs, the research R&D, some industry sectors enjoy the benefit because a lot of the people educated mainstream the deep learning, but the other applied the domains, and where we struggling to hire people who mounted very skillful the deep learning technologies, and who can actually engineering it, who can actually add the values. So because it would be great that environmental studies and geography department, geomatics science and engineering, they can produce their own the graduate who actually already and mounted with the knowledge and skill set, who can deal with in a data centric the math and the programming skill. And then the industry who more relevant to those domain can hire those people and continuously. I think this is very important to graduate teaching those people within those. The problem is the prerequisites. So for learning this deep learning, linear algebra must be taught, and the programming skill must be taught. And as well as we also have to teach them radio transfer functions and how the physics works, right? So the physics part is already taught in academia, many departments, but however, those linear algebras and mathematics and programming skill is not the part of the curriculum in a certain department. So that actually becomes a departure more. So then the people, even though they are interested in and how to combine a data-centric technique with a model-centric one. However, they don't have a skill set enough for jumping in and do some hands-on skill. So I think the curriculum changing is a bit of a problem because prerequisite and the board is as regulated. It's not easy to change, but as a community, we have to pay attention to it, like how we're going to be certification programs, and people take it at how we're going to diminish the boundary between the discipline, so then people can take a certain program from other department and combine together. So and even this CSRS as part of it, I heard that yesterday the AI training sessions run well, but more often, and we can provide an opportunity for people to be learning those sort of a fundamental of it, and then so that they can start to build the ground, so that they can start to mount those data-centric, so which is great. And geographic, environmental, and geomatics, and already know how the physics works and how the conceptual model can be built for managing the forest and ocean. So they just need to understand that how the data can help them, right? How this data can product it. So I think this is very important in future, so that the relevant industry also will gain the benefit because they can directly hire those people from their partners programs in academics.
Indeed, yeah. Thank you so much, Bruno. This was very insightful. I think kind of as someone with a geomatics background and someone that worked in remote sensing for quite some time and still does, I am hopeful that kind of we're seeing a few really good data points that tell us we are equipping ourselves as a community with those latest tools and routines. I think the workshops yesterday is an example. There's a roundtable about a remote sensing certification at this conference as well. So I think these are all good things in working in the right direction. I trust that there are quite a bit of students at this event, so I'll ask some questions about how AI has changed recruiting. Mike, I don't know if you're directly involved in recruiting at Foresight, but if in this day and age, kind of, has GeoAI changed what you look for when you receive a resume?
Oh, very much. I think that within our group, the business unit I'm in is resource management and technology. So it's 80 or so professionals, all of us at a desk looking at some sort of geomatics or AI problem. And in our GIS department, in our inventory group, we're looking for maybe I'm not looking for someone to Gunho's point about I don't need them to come in necessarily with all the background to assist us in creating the AI and that, but absolutely want them to be familiar with it and to not be intimidated or run shrieking away when we say, okay, we're going to label this for use in the model right now. Really the good news on that front is we're seeing the resumes coming out of universities and so forth. The students already know, right? This is where we're going. And even though perhaps maybe forestry isn't at the leading edge of AI implementation across all industries, there's enough of it that every resume I see has some mention of it.
Yeah, thank you, Mike. I wanted to put that question because there was a question that popped up in the Q&A about the minimum educational background required for someone to pursue a career in GeoAI. So I mean, from the sounds of it, it sounds like someone with a mix between geomatics and some kind of computer science skills, whether it is scripting or understanding concepts of labeling and whatnot.
Sure, and in our case, we're of course looking for a forestry background to go along with that in many cases. So we're not going to expect them to have a very high level on the level of knowledge on the forestry side, as well as all of that AI background. But we expect them to be fast learners when we put them into the mix.
Yeah, thank you, Mike. I do want to say that the panelists have been excellent at answering almost every question that came in the Q&A. So I see every question answered in written form. So thank you to the panelists. Hopefully we can share those questions after the session. I'll speak to Celeste and the organizers after the fact, because there's quite a bit of good stuff in there. I'll do one or two more questions, and then I do, even if those were answered, I do want to kind of verbalize some of them. But let's do a little bit of a future look. So on GeoAI and on our industry, kind of, are we? Maybe I'll start with Burns. Are we at a place where I can use a GeoAI pipeline without needing to know too much about a convolutional neural net, or without needing to have a lot of hardware or infrastructure?
I'd say to a certain degree, yes, for sure, and it kind of depends the level you're talking about. You know, if we talk about remote sensing in terms of, you know, orthophoto satellite, I think there's a lot of great products out there for accessing these images, and then you can start drawing boxes in different, you know, web platforms, and look, I trained a neural net. You know, it's certainly a bit of that, and a lot of that's been, you know, a lot of the complexity has been hidden from the user. And even, you know, there's lots of, let's say, Python libraries that you can just go to GitHub and, git checkout, library X, and away you go. That being said, if you want to go beyond, find all the cars in this picture, okay, that's great. Lots of people could do that, though. If you want to get, up to scale, that's the problem, as you know, that we've dealt with. How do you do AI at scale with the big user base that has, literally petabytes of data at their disposal? They need to get all this stuff, processed. So that's where, other people have looked at it. That's something we've been really focused on, is not just, solving problems with AI, but also putting out the infrastructure. So like we've got our Mira AI platform, for example. So we're using, we're leveraging, Amazon's Amazon Web Services, where we've come up with an infrastructure that we can host large scale, systems, large scale solutions for our end customers. So we had to, training the AI was kind of the easy bit. Then I had to deploy it on the cloud. Oh crap, how do I do that? Okay, so that turned into a big thing. But now we've got it, and we've got things like, some of you may know, yesterday was World Hydrography Day. That was exciting, and we actually announced a collaboration between Seabed 2030, or the GEPCO group that's looking to map the world's oceans by 2030, ourselves, and then the one of the largest and oldest mapping agencies in the world, which is the UK Hydrographic Office. So we're collaborating through the Mira platform and the Seabed Foundation to bring this stuff at scale to users that are feeding this massive database of world ocean data. So we're part of that solution to make it easier for GEPCO to manage that data set. You can imagine that they said, hey, please, people, send us your data, and everyone complied. And they're just throwing terabytes and terabytes of data at these guys, and someone has to sift through it and try and clean it up. Well, AI can help with that. So that's the kind of thing that we've been trying to solve.
Indeed. Thanks, Bernson. Happy World Hydrography Day. Okay, I want to be mindful of the time. We have a few minutes left. Before we kind of read out some of the questions, because as I said, fantastic job on behalf of the panel, everything has been answered. Let's do a little bit of an aspirational roundtable. So in the next few years, what is there to look forward to in the world of AI and geospatial? Let's start with Guillaume.
I would say what's going to be one of the big next trends is the closer, I would say, well, two things. First of all, there's going to be a much closer relationship in between the domain and the tools, because maybe to bridge to one of the questions that happened there, what is the minimum educational backgrounds? There are skills related to the domain, and there are skills related to the tools. And at the moment, You see, you have people here from ocean mapping, we have people from forestry, and it's completely different problems, but we have a common core there. So I would say there's going to be a much deeper relationships in between the different domains. It's going to be specialty applications that are going to become standards. The second part of things is definitely going to be the let's call it the security aspects in two ways. So first of all, cybersecurity. Training good AI systems implies large quantities of data, which kind of beg the question of how secure the access and the gathering of this data is going to be. So that's one of the big questions. The other question is, of course, the security of the systems themselves. Basically, how can you trust the data? How can you trust the systems? And how can you trust the systems under adversarial conditions? Because basically, there's going to be people that are going to be trying to game the AI systems. And so far, it's been fairly easy. It's surprisingly, scaringly easy. So just to mention a quick research, if you look up the latest poltergeist attacks on autonomous vehicles, notice that you can actually hide objects. You can make them, let's say, standard neural networks, such as the YOLO object detection that CNN basically miss detections and make the vehicles collide with one another. So there's all sorts of different issues that are going to be addressed in order to bring up the public trust into these systems, because as Mike mentioned, trust is basically the biggest driving force behind the resistance for these systems, and there are lots of issues to be addressed in that matter.
Thank you, Guillaume. Same question, send it to Bruno. What are you looking forward to in GeoAI for the next short while?
Yeah, so the first thing is that for me, the science, we practice in science. The science is all about how we're going to make natural phenomena explainable through the science. And the neural network can do what it is, and this is an object, and what kind of object, what state of the object. They identified it and they predicted it, classified them. But it doesn't then tell and how it's going to be progressing, how it is going to be integrated with the physical model. So how this tree grows and how the healthiness of the trees and the water conditions and the water dynamics of waters and hurricanes. So how this data-centric observation and a prediction can be integrated with physics. At the end, how contributed to understanding about our nature phenomena, right? So how it is going to be contributed to science. So that's sort of our communities are particularly interested in, and which not much studied yet. So we continue to collaborate with computer vision scientists for understanding better and augmenting our capacity for how data works. And then, however, our job is to take those understanding and technology, plug into the physics, and then the understanding science better. I think those marriages is still, I think that's what I'm looking for. Second is, again, neural network practice so far we developed is very expensive and a very exhaustive way of learning. So continuous learning, kind of, I'm learning it and then they naturally learning better. And when the new data is in, and on the other hand, how is make it practically a lightweight of the networks can be plugged into small devices to working. Or like a lot of a practitioner we have is they actually working on field, and how we're going to make them utilize the networks while they working on the field with very limited resources. So I think those are I'm particularly interested in.
Thank you. Andrew, same for you. What are you looking forward to?
Yeah, I mean, I think, somewhat selfishly as sensor manufacturer or as someone who works for a sensor manufacturer, I'm really interested in sort of, edge computing and bringing those AI algorithms closer to the sensor and being run as you're flying so that you can make decisions, before you land or before you go home to the office. And I think that is particularly true in the remote sensing and the LiDAR space, because, I once, somewhere in my travels heard someone say that, a traditional surveyor's core skill set is actually in data reduction, right? So anyone with a prism and a total station can go and, collect a few points, But really the surveyor's expertise is in knowing which points to collect in a minimalistic way to represent whatever they're trying to survey. So, you know, on the LiDAR and remote sensing side, we sort of have the opposite approach where we plaster everything with points or with pixels and you know, just gather everything. And there's value to that approach as well, in terms of, you know, being able to reuse the data and things like that. But, you know, I'm excited to see if we can sort of make that shift backwards to say, okay, you know, what is the information that we actually care about, so that you don't have to carry around these, you know, terabyte or petabyte data sets. You know, you're only getting the information you need and the answers that you wanted in the first place.
Yeah, excellent. Thank you, Andrew. I think you're winning now with the best tagline. The surveyor's job is fundamentally data reduction, or it's a tie with everything is somewhere. Mike, same for you. What are you looking forward to?
Well, yeah, I just to sort of carry on from what Gamo was saying, the opportunity on the forest side is really to sort of move from this static analysis. With, you know, we bring in all our inputs, we predict species, volume, log size, everything across an inventory base, and then we basically walk away from it because the systems haven't really been put in place to continuously learn and feed from that. And I think there's a huge opportunity to get better here. There's a movement in the technology where we're harvesting the forest, where we're able to measure the diameter and the length and the species of every log that gets harvested. Well, we should be using that to go back into our model and then refine what's out there, because, you know, we never have enough labeled data going in. And so, and we could be creating and adding hundreds and thousands and tens of thousands of examples on a regular basis and just making our model better. And I think that whole sort of dynamic digital twin look is where I think it's going to go at some point here anyway.
Mm-hmm. Wonderful. Thank you, Mike. Celeste, I know we're 1 minute over. I'm gonna last but not least, I'll do Burns, and then I'll do some closing remarks. Is that okay, Celeste?
Yes, that's not a problem. There's nothing scheduled in this room after you.
Great. Okay.
Did we get to Guillaume, or did I miss something?
No, we did.
Okay.
We did
All right.
Guillaume.
I tuned out for a minute then. Sorry about that. Well, no, the reason I ask is I wanted to actually bring it back to something he said early on, and that you know, there's been a lot of hype around deep learning, and for good reason. It is quite useful, but what I'm looking forward to is kind of like he said, coming back to kind of the core, you know, concept of AI, where it's not just these neural networks, but it's other algorithms and other things we can wrap around these neural networks to get around their limitations and make something really, you know, interesting and robust. And we get into truly intelligent systems that, you know, you can push a button and say, hey, drone, go map that thing, and the drone makes the decision about how to map that. Or you're underwater and you say, hey, boat, go find me a shipwreck, and it'll just go out and find a shipwreck. You know, the operator doesn't need to program the flight path or anything else. Everything just becomes easier. And so we as the people, as the operators, can focus on what we need to focus on. You know, the interesting thing, what is the answer, just like Andrew said.
Mm-hmm. Fantastic. Yeah, so I mean, it's interesting. All of the panelists had very similar aspirations. I think kind of two of the common themes I heard was bridging the gap between the tool specialist, the person or the team or the group that develops the techniques, and then the domain experts, the people in forestry, the people in hydrology, the people in kind of analytics for the built environment. So that bridge is going to be quite important as we move in time. And then likewise, the development of systems that are smart, that are able to make decisions and conclusions, and ones which have some kind of edge computing that can enable the collection and the delivery of insights rather than just massive amounts of data. Yeah, this is fantastic. I think this is a good place to to end this conversation on. Celeste, do people have access to the Q&A in a written form?
I will be able to save that out for you and then send it to you.
Yeah, that'd be wonderful because, again, the panelists, I'm grateful for them. They did a fantastic job at answering every question. So I chose for that to be written. But I'm sure there's some people that maybe were not tuned into the Q&A that would like to see the answers of the panelists. So it'd be fantastic if we can share afterwards. But yeah, with that, we are 5 minutes over. We come to the end of the GeoAI session at the Canadian Symposium for Remote Sensing. I want to thank the event organizers for the opportunity to have this. I want to thank the panelists for being really thought leaders and innovators in their own right and in their own domains in different parts of Canada, in the geospatial, the hydrospatial, and the AI world. And I want to encourage the attendees to reach out to us. We love doing this kind of stuff. We are keen on making sure that anything that we develop is being used and reused and broken and fixed and just sliced and diced. And yeah, we like this. So please reach out, stay well, and enjoy the remainder of CSRS this year. Take care, everyone. Thanks, man.
Thank you, Malik.
Thank you, Malik.
Cheers, guys.
Thanks,
Thank you.
Malik.
Thanks, all.
Thanks, Malik, Celeste. Thanks, everyone.
Celeste, Chris, thank you very much.